Hey guys, welcome to another math help video. In this video, we're going to be doing solving equations by completing the square, 9.5. If you're doing this, the week of the assignment, which I would think you are, this is the only assignment this week. There were 3 lesson videos, but I crunched it all into one single assignment. There's 3 kinds of questions. Each of the 3 kinds of questions doesn't really quite come from all 3 videos. I'll show you what I mean as we're going to the questions. Anyways, let's do this. We're going to solve some equations, but we're going to have to do it by completing the square. So the first question is, well, what is completing the square? And that's what the first few questions of the assignment are. They are asking you to complete the square. So first, let me write this guy down. V squared 14v plus something. Completing the square means you're adding on a third piece of a trinomial. It's called a trinomial because it has 1, 2, 3 parts. Completing the square means you're adding just exactly the perfect number on the last spot that would allow you to be able to factor this thing into a singular parenthesis squared. That's why it's called completing the square, because you're taking the 3-part thing and condensing it into a 2-part thing squared. But you can't just condense it automatically. You have to have a particular set of numbers. So they're asking you in this the first couple problems here, what particular number has to be added so that it's perfectly squareable. And it's honestly not that hard to find. So here, let me write some stuff in red here. So what you want to do is this. That middle number, 14, half of that number is like a key number in this situation. So half of 14 is 7. So 7's like an important number. In fact, if you were to condense this, you're going to end up writing v plus 7, and that's what the condensed version would be. Now, that's not the answer to the problem. The problem would be what number goes here at the end? Well, that's what you get when you square this particular special number. So the final number would be 7 squared. So basically, here's how it works. You have v squared. The middle number is some number times 2, in this case 7 times 2, and that same 7 is squared at the end to give you the final number. So in this case, the final answer is 49. I think I made that harder than it needed to be. It's okay. We'll speed it up each problem. So here's how I did it again. Quick steps. Half of 14 is 7. 7 squared is 49. Therefore, v squared plus 14v plus 49 is a perfect square. This is what number makes this expression a perfect square, because you would be allowed to factor that into v plus 7 squared. Another one, y squared plus 16y plus, okay, so again, here's the steps. Half of 16, I'll write this and write it down, I guess. So in this problem, our particular middle number is 16, so we divide that by 2, and that gives us 8, and then 8 squared is 64. And there you go. That's the number we need here. This will become a perfect square if you put 64. Just so you guys know, the middle term could be negative. I don't know if I'm going to see that. I have one more problem to potentially see it. Oh, here we are. Yes, a negative. If the middle number is negative, that's totally irrelevant, because technically you're squaring the negative number. So let me show you what I mean on this one. So on this one, the middle number is negative 10. And if I divide that by 2, I get negative 5. But negative 5 squared, when done correctly with parentheses around it, as you should, it makes 25. So no matter what, you should be putting a positive number at the end as you complete any square. A perfect square trinomial, which is what we're making, should always have a positive third plane number term in there, assuming everything else is fine. Now, I think on, how do I describe this? I think on the lesson, they got more complicated. Like, it didn't always just have w squared. It had, numbers on it, like 4w squared, which, to be honest, is kind of a mess. But how would I even describe that? Can I even hold on? Let me even think if I could make up a problem right now that even works with that. 4w squared plus, okay, I got to choose something good here. That's not divisible by 4 exactly. 50? No. Okay, hold on. 16W. Okay, sorry. Trying to make something up here. If somebody said, hey, what's the perfect way to square this or whatever, that's harder. Number one, everything is divisible by 4, so that kind of messes everything up. Number two, yeah, I mean, I guess what you would want to do is this. To get 4 is actually a 2, so it's 2 times something times 16. So instead of taking half of 16, you would take 16 and then divide it again by 2, which was the square root of this first number. That's a mess. It's a mess. It's a mess. You don't want to do it, right? I don't think they're going to force you to do that on Alex. And honestly, if you were completing the square, you'd probably be doing it with more basic cases. If we see one of those on the next couple problems, well, we'll see one and I'll do it, okay? All right, so that was the first 3. All we had to do is pick the number that is needed to make it perfect. Now on this next set of problems, the majority of the assignment, which is the main thing to need to know how to do, they're going to give us an equation. So here we are. We got x squared 10x 12 equals 0. Now here's the problem. 12 is not a perfect square. If I took half of 10 and I squared it, I would not get 12. But I will get a number that's important, and I'm going to use that number in a second. So here's the deal. The number that's already written there, which is what you're likely to see, is not wanted. So what we're going to do is we're going to get rid of it. We're going to move it to the other side. So we're going to minus 12 on both sides. X squared plus 10x equals negative 12. Now here's the deal. Here's what this whole chapter is about. It's called How Do We Solve Equations, right? And we've seen how you can solve them by just taking the square root of both sides. Like, let's say there's no 10x here. We could move the number over and square root both sides, right? Although it would be bad to square to negative. We've also seen how to solve them if you can factor it. Right now, we can't factor it. There's no numbers that multiply to make 12 yet add up to make 10. So I couldn't have factored it into 2 parentheses and then done the zero product property as we did last week. So this is why we're doing this process. It's because this is a different way to solve it. If you don't have something you can factor and you don't have something you can just square root, then this is a third option. This option pretty much always works. The problem is you don't always want to do it. It's better if this middle term is even, like 10. Sorry, I had to interrupt there to explain why would we even do this process, right? It's called, this is how you solve an equation like this if you can't factor it and you can't just use the square root only. Like if it's not just x squared. Probably should have started the video with that one. All right, whatever. All right, so we moved the 12 over. Now here's the problem. I can't factor this, but I want to factor it. So the question is, what can I add to make this something I could factor? Well, here's what we can do. Complete the square. So what number is half of 10 and then that same number squared? So half of 10 is 5. I'll do a little work off to the side here. 10 divided by 2 equals 5. 5 squared equals 25. So to complete the square, it's fair game if I add 25 afterward. And that's kind of like what we were doing on the first problems, right? Except in the first problems, they were just asking us to find some number. Here, I'm solving an equation, and I can't just flop 25 on the problem and call it a day. That's not balanced at all. You can't do that in math. However, I can do this. If I had 25 to the left side of the equation to complete the square, then it is possible to do as long as I add 25 to the other side of the equation. There, I added 25 to both sides. That's fair game in math. You can add whatever you want to both sides of an equation. But why did I do that? Well, 2 reasons. One reason only. Number 1, I want to complete the square. And why do I want to complete the square? Because now this fella can be factored. What times what makes 25, yet adds up to 10? The answer is 5 and 5. Now what you're going to find as you do completing the square is that when you do this little factoring, it should always be something times itself. Like it should always be that number that was half of the middle. In this case, half of 10 is 5, so it should be 5 and 5. If this was a negative 10, I would use negative 5 and negative 5. So that is where something important comes into play regarding the signs. Okay, so what's going to happen is this. If this is 5 and 5, then wouldn't it be fair game to write this as x plus 5 times x plus 5? And this other side, you can't just like leave that like that. Let's add those together. Negative 12 and 25 is 13. Okay, but this isn't quite the way we want to write it. We actually want to write it by doing x plus 5 squared equals 13. That was the whole purpose of everything we've done so far. It was called, okay, we need to move this 12 over because I can't factor the way it is. I added a new number in, which allowed me to factor it. And then instead of writing the thing out twice, which is what you should get every time, I'll just write it as a single thing squared, and it equals 13. And that answers the first part of this question, which says form. Now there's a plus and a minus because they want you to know if it's a plus or a minus. I'm getting x plus 5 because I had two positives 5. So x plus 5, and it equals 13. There we go. I completed the square and used it to simplify this equation. Well, how is this simplified, I guess, is the question. Well, because as it is, it's now something we can solve using what we used a couple weeks ago. Yeah, remember at the beginning of the problem I said I couldn't square root anything? Well, actually now I can because it's all just one thing squared. So now it's fair if I want to square root both sides. And when you square root the squared thing, it makes x plus 5. And remember, it's been a few weeks, but if you square root some plain number on the other side, it becomes a plus and minus of that. There's two different answers. But we're not done. Just like the lesson a few weeks ago, you can't just leave x plus 5 over here. You have to minus 5. And again, you can't combine things in a root with things not in a root, and you definitely can't combine things with the plus minus sign. So the answer is this, negative 5 plus or minus the square root of 13, which is really two answers. The answers are negative 5 plus root 13, negative 5 minus root 13. Those are the two answers. And yes, I know that was a lot of problem. That was indeed a lot of problem, and nobody said completing the square was a little bit of problem, so I apologize. Hey, that's why you're getting one homework assignment and not two homework assignments. Surely you can find the willpower to do 4 of these. There's only 4 of these. Well, okay, there's 4 like this, and then there's 3 others kind of like this too. Not sorry. All right, anyways, let me recap the steps here. So we had the original equation. I don't like the number that was there for C, so I moved 12 over. I made a new C that was the exactly perfect square number, and how did I find that? It's half of the existing B value, 10, squared. So half of 10 was 5. 5 squared is 25, so therefore I put 25. But if I do it on one side, I do it on the other side. That allowed me to factor the left side, x squared plus 10x plus 25, into x plus 5 and x plus 5. But instead of writing x plus 5 and x plus 5, I wrote x plus 5 squared, because that's cleaner. And then I solved that little x plus 5 squared equals 13 mess by square rooting both sides. And when you do that, you get x plus 5, and the 5 needs to move. And then I had negative 5 plus or minus the square root of 13, which is really two different answers. Whew. Just so you know, while you're doing the assignment, this left thing right here at the bottom, that's part of the answer. So you want to stop there and maybe input that before you continue solving, because it'll ask you to put it in the perfectly squared and single binomial squared form. And so you're going to be asked to do that. Now for the solution here, Alex doesn't care if you put it with these roots. In fact, I don't think it'll let you. So I will need to put those as actual like decimals or whatever. Plus square root 13. Negative 5 minus square root 13. All right. Make sure you round good. It'd be a shame to round wrong and get stuff wrong. 1.39. That's the nearest hundredth. That's what they wanted, right? Yep. And negative 8.61. Because the 5 rounds that 0 up. Should be right. I hate doing the first one because it's like should be right. Oh, but was it? All right, let's do another one. I have bad news if you're sitting here going, okay, he's going to show me the faster way to do this, right? Not really a faster way to do this. In fact, because this problem asks you to write it in the correct form, you can't really cheese it. There are ways to get the answer without doing the work, but you can't get this first answer about the form unless you do the work. Like, it's impossible. So you pretty much have to do it. All right, so we have x squared 18x plus 76 equals 0. Now here's the deal. Half of 18 is 9, and 9 squared is not 76, so 76 is not a good number. So just like last time, we'll move 76. And I already talked about what's going to show up here. I'll leave a little space because we're going to add our preferred number. which is half of 18. I'll do this off in the corner here. Oops, I'm thinking of the answer. Is 9. And then 9 squared is 81. And don't forget to square it. That's important. Don't just put 9. You have to square that number. So it is appropriate to add 81 to this side. And therefore, if I add it to the left, I add it to the right. And why did we do that? Because that allows me to figure out what multiplies to make 81 and adds up to make 18, which is 9 times 9. Positives, because they add up to positive 18. Sometimes you'll choose negative, negative, and sometimes you'll choose positive, positive. It really depends on what the middle number is. And honestly, you don't even need to write this thing out here. In my mind, you should be able to skip all that and just immediately jump to the answer, which is x plus 9 squared. Notice I didn't bother writing x plus 9, x plus 9. I just said, it's got the same thing twice, so I'll just write that squared. And then the right side will turn into a whole new number, 5, because negative 76 plus 81 is 5. Now, I put my stuff down here because I would have to write that down. The form is not x plus 9 equals 5. Okay, now for the solution. Do it the same as last time. X plus 9 equals 5. Sorry, that's a little small in the corner there, but it is what it is. I square root both sides, and I get x plus 9, not in a parenthesis, plus or minus. Every time I write an equals, it makes a little junky equal sign. Plus or minus the square root of 5. Not the best looking 5 either. There we go, a little better. Okay, and then I minus 9 on both sides, and I get my answers. I get negative 9 plus root 5, negative 9 minus root 5. Notice I kind of cut a little bit of steps out here compared to the last one, because there are places you can cut it down, and I did. So like I didn't bother writing the expanded form of the thing. I just wrote it one thing squared. And then on this over here, I didn't bother writing plus minus. I just wrote the two answers right away. I need to go back and find the two answers. Negative 9 plus square root 5. Negative 9 minus square root 5. Okay, then I'll write those as my solution. Negative 6.76, comma, negative 11.24. Make sure you round everything okay. Ooh, itchy nose. Ah, so much better. Oh, okay, good problem. So far, all the problems we had this like negative number here, and that's not always the case. And this one will be a little bit different, if not a little weird, because it's going to have ones. All right, so let's do it again. It's in blue. Hold on, let's make it in black. X squared minus 2x minus 6 equals 0. So step 1. I don't like this number at the end, so I'll remove it. This time I'm adding to remove it. How nice is that? So I get x squared minus 2x. I'm going to leave a little space, equals 6. I'm leaving a little space because we need to figure out what the perfect number is here. So half of negative 2 is negative 1. Negative 1 squared is 1. So I'm going to add 1 to both sides. Now notice, though, despite it being negative, I didn't subtract when I put that extra number in. This is where you got to be so careful. You notice how I'm putting this negative 1 in parentheses? If you do not do that, and you punch it in a calculator just to check your work or whatever, it's going to spit out negative 1. And, like, watch this. If I don't put it in a parenthesis, it says negative 1. That's wrong. If I put it in a parenthesis, oops, it says 1. So there's a difference because it thinks here you're doing negative 1 times negative 1, which is the right thing to do. And here it thinks you're doing 1 squared and then making that negative, which is the wrong thing to do. There's like an order of operations going on here that you don't want to mess up. So be very careful, okay? Anyways, now that I've added 1 to both sides, I can write this. Now I'm not even going to write the x this time. I'm just going to write it as x minus 1 squared equals 7. I saved even more steps. How did I know to write this exactly as x minus 1 squared? Well, minus 1 was the half number, and therefore that's what I put in here. Whatever the half number is, you're going to put x and then the half number, just like that. Now here's the deal, though. You weren't allowed to just start the problem off by writing it like that. Like, I couldn't do that up here until I've moved the 6 over and then added this extra 1 to both sides. Because if you don't do the step of completing the square and adding the 1 to both sides, you're going to end up getting 6 over here on the right, which is not the right thing. It's not the correct thing to have. So make sure you do I know you're probably like, no, I don't want to write more, but you got to do the process or you're going to have a wrong number on the right-hand side of this equation here. All right, so now I've solved that. Now we do the rest of this, just like we did on was it 9.1? Or was it 9.2? I think we did it on 9.2. 9.1 was graphing. Wait, did we do it at all? I can't even remember what lesson we did this on. Hey, we did it though. Maybe it was 9.4. Oh, 9.4 had everything. Yeah, that's right. This was all on 9.4. I thought this was just the other week. So I square root both sides. I get x minus 1 plus or minus root 7. I add 1 to both sides. Please be aware you don't want to add the 1 with the 7. That'd be wrong. You get 1 plus root 7, 1 minus root 7. Those are our two answers. It would be so nice if Alex made you actually write the root things. The reason why I say that is because when you're taking a I don't know, a standardized test or something like that, you may have to input the answer exactly instead of as a decimal. And the reason why that matters so much is because there are ways to get the answers much quicker, but they'll give it to you in a decimal form, and it's not an exact answer, and it's honestly not good. So I'm kind of sad that Alex makes you put it in as a decimal form. But it is what it is. Well, what are you gonna do? I'm not the designer of Alex. Although if they, wanna hire me, I ain't gonna be mad about that. Okay, I rounded good there. On this last one, I'll show you kind of the cheesy way to do it. And here's what I mean the cheesy way. I mentioned this at the end of another video a while ago. So if you're seeing it now, good on you, I guess. If I type in the equation, which I'm sure some very enterprising students will have tried, they'll say, okay, this gives me the answer, right? Because that's what everybody goes. They say, if I plug it into the calculator, I get the answer, right? Desmos always gives me the answer. In fact, if you photomath this, I'm sure it'll give you the answer too. I can't help but wonder if photomath would even tell you how to write this with the square roots and stuff. That'd be convenient. Anyways, check it out. If I graph it, it gives me these decimals. Which guess what? I mean, I hate to spoil it, but those are the answers. 6.57, no 9, because I'm rounding up, and 9.41. Those are literally the answers to the problem. The second part of the problem, and this is why I haven't shown you this yet, because it doesn't help you in any way figure out what to do about the first part here. Kind of. You could probably, if you're kind of like a smarty pants, figure it out. Like you could say, okay, half of 16 is 8. 8 squared is 64. Okay, so the 8 matters. There's going to be an 8 in one of these things, and it's going to be a negative because that's negative. So I can put an 8 here. And if I had moved the 62 over to the right side, it would be right side. Sorry, the camera reverses. To the right side, it would be negative 62 plus the 64 I added makes 2. See how I got that right all of a sudden? Now that is not a good way to do it. So let me explain what just happened. I graphed it. That gave me the answers as decimals. Woohoo! And then I did a little mental gymnastics to figure out what numbers would become here. That's not really the best idea. Okay. Now, we already know I was going to get it right, but I do feel like I need to show you here. So if you feel like you want to see an additional example, follow along. We got x squared, 16x, 62, 0. We want to move the 62. I'm doing this one all in black, by the way, because I'm just too lazy to change it. Okay, we add 64 to both sides. Why am I adding 64? Because half of 16 is 8. And 8 squared is 64, so that completes the square, and that allows me to turn this into x minus 8 squared, and this equals 2, because negative 62 plus 64 equals 2. And notice I used a negative 8 because the middle number was negatives, and so negative 8 times negative 8 makes positive 64, and then that's the reason why I wrote my answer the way I did on the left over here, right? And then from there, what I would have done is work this out. Now, I did not work this one out mentally. By graphing it on Desmos, it showed the answer to me. But I can get the exact and best answers right here. So if you were trying to get those, you'd say x minus 8 equals plus or minus 2. Add the 8 to both sides. And there's your answers. X equals 8 plus root 2. And x also equals 8 minus root 2. And if I went over to my calculator device here, and I did 8 plus square root of 2 and 8 minus square root of 2. Wow, would you look at those numbers right there and compare them to what the graph showed me? Those are the numbers, right? You'll notice the graph cuts it off after 3 decimals. I mean, it doesn't matter how many decimals are here. It's not accurate. If I was able to, as the test giver, I would make the person taking the test enter 8 plus root 2 and 8 minus root 2 as their exactly correct answers, which would be impossible to find using a graph like this. I have no idea how a photomath would do it, but it might have the power. I couldn't tell you. I don't have photomath on my phone, and I don't plan to. Whew, okay, so that was some fun problems. Now they're asking us to do 3 more super fun problems. How much time we at? 26 minutes. Oh my goodness, we're gonna make a 40-minute video today. All right, it says, here's a formula, 3x squared minus 24x plus 47, and they want you to convert this into vertex form, which is structured like this. It has a number out front of a parenthesis, x minus h squared plus k. Now, just so we're familiarizing ourselves with stuff we've already seen, I'm going to write some stuff here. If you recall, from quite some time ago, we had a lesson where we saw stuff in vertex form written like this, and we were supposed to analyze what that meant. And just to recap, the minus 4, or anything in here with x, moves it left and right. So the minus 4 moved the vertex over 4 to the right. The plus 5 at the end move it 5 up. So you can see how the 4 and the 5 come into play. They moved it over and they moved it up, right? What the 2 does is it stretches the graph twice as tall as it ought to be. And so we did see that. We did move some of that around earlier this week. Not even this week, sorry. This month? Month? Question mark? Yeah, maybe. Maybe last month a little bit. No, it was this month. Okay, now what they're asking us to do is take a standard form, a thing that's been expanded, and turn it back into this vertex form. Now, turning vertex form into standard form is pretty easy. You take the squared thing, you write it out twice, you do foiling, you distribute the a value, add stuff together, and blah, blah, blah. You got it. To turn it back into from standard form into vertex form, you have to complete the square. So I'm going to do that now. And you better buckle up, buckaroos, because it's going to be a problem. I'm going to write the whole thing exactly as it's written down here. Here we go. Okay, so a couple things. Thing number 1 is that 47 is not exactly a good number. Like, as it's been in all the problems we've seen so far, the C value was not ideal. So we're going to remove that, but we're not going to remove that by removing that. Does that make sense? I'm just going to leave it where it is for a second, but pretend I don't care about it. So let me show you what I'm talking about. So I'm going to write 3x squared minus 24x. I'm going to leave a pretty sizable chunk of space here and then put plus 47 down here. So plus 47 is just a loner now. Like, who needs it, right? Right. Okay. So now here's what we're going to do next. We have to find the perfect square. Now, I mentioned this earlier about it could be troublesome if there's a number in front of the squared term, right? And well, that's what we got here, and that's what we're going to see, I think, on all the problems. So here's how you fix it. If you look at the a and the b, 3x squared and 24x, those are both divisible by 3. So we're going to do that. So I'm going to write g of x equals 3 outside of a parenthesis. And I'm going to write x squared minus 12x. Now, I could have divided them both by x. That's a thing that they're divisible by, but please do not. We do not want to divide everything out. We just want to remove that front number if we can, because it's kind of blah. And then this little gap here is going to be still hanging out afterward. now with a new parenthesis. 47 didn't get divided by 3, so it's just going to hang out over here. Okay, now we're going to complete the square. So let's ignore the 3, let's ignore the 47. What's half of 12 squared? So half of negative 12 is 6, and 6 squared is 36. So I'm going to add in a 36 right here. Okay. Now, on the previous problem, we had to add it to both sides, right? Two things. Number one, the left side doesn't have 0 like before. It has g of x, and I kind of just want to leave g of x as g of x and not do it. So here's an alternative. Instead of adding 36 to one side and adding 36 to the other side, you could add 36 to one side and subtract 36 on that same side. Like if you add and subtract a number on the same side, you've essentially done nothing, and therefore you haven't messed anything up. So I'm adding 36 and I'm subtracting 36. Except I'm not going to do 36. The reason why I'm not going to do 36 is because, see this 3 that we pulled out? That's also affecting the 36. So technically I need to, I'm not just adding 36, I'm adding what was 36 that's going to be multiplied by 3. Just for your reference, 36 times 3 is 108. So if I add 108, then therefore I need to subtract 108. I hope that makes any semblance of sense. So let's recap our steps. This is all the critical stuff here. So once we got this down, we'll be going straight to the answer pretty much. So here we go. We had the formula. We pushed 47 over because we don't want to mess with it. We had a number in front of x squared, so we divided that out. And then we completed the square, which was 36. But because we had divided the 3 out, 3 times 36 is 108. So we weren't really just adding 36, we were adding 108. So if we're adding 108 via the parentheses, we needed to just subtract 108 outside of the parentheses to be balanced. Okay. Wait a second. Oh man, I drew a dot somewhere in here. Whatever. Figure it out later. All right, anyways, time for our answer. You're probably like, what? Time for our answer already? Yeah, it's time for our answer. Well, start the answers, I guess. So the 3 on the outside stays on the outside. Don't mess with it. The stuff on the inside turns into x minus 6. How did I know that? Because half of negative 12 is negative 6, and negative 6 times negative 6 is positive 36. So basically I could have written x minus 6, but you don't want to do that. You just want to write it as a single thing squared. And then at the end here, the 47 and the negative 108 combine together to make a new number. So 47 minus 108. I guess I'll do it on a calculator. Not that much. Negative 61. Wait. Did I do that right? Oh, I have a problem. Okay, hold on. Yeah, I do have a problem. It's called that ain't right. What did I do there? I have concerns. Okay, hold that thought there. So this 3 and x minus 6 is looking pretty good. The 47 over here is okay. I can't do 61 because that wouldn't fit on the graph, and they definitely want me to pick a number that will fit on my graph. So where did I make a boo-boo here? Should I have just used 36? I can't have just used 36. That'd be crazy talk, right? Well, the good news is we can always check using our handy dandy Desmos here. Let's just type in, oops, 3x squared. This is advisable to you. If you can't find stuff you're looking for and you pull a me, definitely use the oh, that's a boo-boo right there. Okie dokie. Yep, I know exactly what happens. I did a math wrong. I wish there was people here to tell me I did a math wrong. Okay, we're going to correct it. Then we're going to do a better job on problem number 2. Oh my gosh, that was a bad problem number 1. All right, here's my problem. I divided 3 here, and this was actually not 12. 24 divided by 3 is not 12. Duh. This was an 8. That's gonna hold on. We got some changes here. So half of 8 is 4. And okay. Corrections time. So half of 8 is 4, and 4 squared is 16. So I should have added 16 to this side, and triple of 16 is 48, which is what I should have added on the outside. No, not added. Subtracted, just like we had done before. Because I'm adding 48 inside, I got a minus 48 outside. Okay, that's better. And that means this is 4, and negative 47 plus 4, negative 47 minus 48 is negative 1. Better. So sorry. So, here, okay, let's go over the steps here. So, we move the 47. We have this 3x squared and 24x. I divided out 3, which I appropriately turned into 8. If you were sitting there screaming at me because you're like, wait, shouldn't that have been 8? Well, okay, it's fixed now, sorry. Okay, and then what I did was I completed the square. Half of 8 is 4. 4 squared is 16, so I added 16. I had a 3 on the outside, so 3 times 16 is 48. So I had to do the reverse of that, which is minus 48 on the same side to account for the fact that I added 48. Whew. Then I had 3, and then this whole trinomial turned into x minus 4 squared, and the outside stuff turned into negative 1, and now it is in the form specified. Minus 1. Whew. Now, if you notice, though, I graphed it, and I'll use this to make my point here. If you want to check to make sure you're right, I mean, write the thing that you had gotten, and if they overlap, definitely you have a right answer, because if it's the same thing, you rewrote it correctly the same, right? Now, it does ask for the vertex. You could get the vertex from this equation. It should be the opposite of the thing with x, which is 4, and then a minus 1. But you could also tell that from the graph anyways, and that includes the original graph you could find the vertex on, right? Now the question is, how do you graph it from here? Oh, geez. So now you got to graph it, right? Now, I'm going to try and graph it using the methods I told you guys about earlier in earlier lessons, which was this. Start with a vertex, 4, negative 1. And then what I said earlier was the next step is to go over 1 and up 1. Unless you have a number multiplying up front, which is 3. So instead of going over 1 and up 1, I'll go 3 times as much up. So over 1 and up 3. Over 1 and up 3 this way. Okay, we're getting there. And instead of going up 2 and over 4, that's the normal thing to do, you'll go up 4 times 3, which is 12. So I'll go over 2, and I will go up 12 all the way to 11. And 11. Now, if you're like, I don't like that, I don't know how to find that, I'll tell you the same thing I told you before, which is if you graph it on Desmos, you can click the gear and make it a table. Now, the table will not provide you with everything you need. You'll have to actually put in some numbers. So you'll want to put in stuff like 4, 5, 6, and 4, 3, 2. And those are the points I just plotted right here. That was a problem, wasn't it? Now here's the deal. I'm going to go back and revisit that on the third one, just showing you that you can kind of cheese it by graphing it if you have a graphing device. But I'm going to do the next one legit and not mess it up. So hopefully, it's not that bad. Here's the graph there. I'm going to continue to the next one. All right. Let's do a little better this time. Oopsies, that last one was a little bit of a boo-boo. So write the whole thing out. F of x equals 2x squared. I mean, imagine being a math teacher and then accidentally, kind of, sort of, forgetting about the concept of dividing by 3. We're going to do it right this time. Except for this time, I can't mess up because I'm going to divide by 2, which was the thing I tried to do accidentally last time. All right, anyways. So we have this equation. You notice I left a little gap here to remind me that I'm going to be adding some extra stuff, and the 51 is like my outcast. And this time we have a 2x squared. So what I'm going to do is I'm going to divide by 2 to the outside, leaving x squared plus 10x. And yes, this time it's definitely 10 because I'm dividing it by 2 and not being a dupe. And then 51's chilling out here. So now we'll complete the square. Half of 10 is 5, and 5 squared is 25. So I'm adding 25. And on the last problem, what we did was this. We had to take this front number and multiply it to the perfect square, which is 50, and then subtract that outside of it. Because I'm adding 50 essentially by putting this 25 times 2 on the inside, so therefore I'm going to subtract 50 on the outside to make everything balanced. And what that allows me to do is say, okay, this is 2 times x plus 5 squared plus 1. There, answer. Wait, where did all that stuff come from? X squared plus 10x plus 25 is a perfect square because it's 5 plus 5 and 5 times 5, and therefore x plus 5 is what this becomes in here. And 51 minus 50 is 1, and there we go. Voila. So now if I were to write this, I'd write 2x plus 5 squared plus 1. The vertex is at -5, 1. Without even graphing it, I can know that because of the way the structure of this is. That's why it's called vertex form. You should be able to look at it and see what the vertex is, right? It's opposite of the x thing, so -5 plus 1. In fact, let's graph it. -5 up 1. And then, just like before, you can start there, and instead of going over 1 and up 1, it's over 1 and up 2, because it's times 2. And the normal thing to do is to go over 2 and up 4, but instead of going up 4, I'm going to do 4 times 2, which is 8. So over 2 and up 8, all the way up to 9. And there, it's graphed. Now this is where I'm going to segue into the other way to do it. You could graph the original, or graph your answer, I guess, and it'll still show you the way your graph is supposed to look. So if you're having trouble with the graphing part, if you at least type in the original, it'll still give you the vertex, and it will still give you a rough way of how to graph it. And again, you can convert it to a table. You'll have to delete some values and change them. -5, -4, -3, -6, -7, and look at those. Those are the points I just graphed right there. So at the very worst, you could do that, right? Now, on this last problem, I'm going to show you the illegitimate way, let's call it, of how to do this. So I'm going to type in the problem as it is. And this is why I'm saying it's illegitimate. Because number one, I got 2. Oops. I got 2, -1. There's the vertex, right? Okay, now if 2 is the vertex, I could use my logic to say this should be 2, 3, 4, and then lesser numbers, so 2, 1, 0, and see how it makes the 5, great points. So over 2, down 1, over 3, down 3, or this, 0, -9, and that, right? So voila, without even actually doing any completing the square, I'm able to figure out that the vertex is 2, -1, because that was on the graph, and I can find the other points by converting the graph to a table, right? So the question is, how do I make the equation without having to do all the work? Well, I'll tell you. The a value is always whatever the front here was. So if this was -2, the a value is going to be -2. If that's the number in front of the first term, which is considered the a value, we have ABC. That a value from the standard form is the same as the a value in the vertex form. So if that's -2, this is -2. And on the last problem, it was 2. And then vertex form was 2. And on the first problem, it was 3. And the vertex form was 3. Okay? Now, because we know what the vertex is based on the graph, we can just reverse engineer some vertex here. We can write x minus 2 squared minus 1. You only have to keep in mind that the x thing should be reversed. So if it's a positive 2, I'm going to write a -2. And if the y value is -1, then yeah, I'll write -1. And there you go. And if you just want to be sure that that was the right thing to do before you even hit the enter button, you could graph it just to confirm that it covers the other graph, and it sure does. So there you go. That was a way to like reverse engineer the answer. I'm going to show you one more of that just in case you're confused. So for this one, I would say, okay, if I want to skip the work, quote unquote, I graph it. You have to graph it on something. I get -5, -2. You do a little bit of work to graph it, so -5, -2. Then I'm not going to bother showing you all the steps on how to get that, but it should be these values here. It should not be those values there. I'm going to undo that. Okay, fine, I'll convert it to a table and do it the right way because it wanted to get mad at me. 5, 4, 3, 5, 6, 7. Okay, where did I mess up? Oh, these were 10s. I put 7s. Oh, duh. Okay. Anyways, let's see, back that up. Let's make them 10s. 10, 10. Ah, much better. Okay, so now writing the equation. There was a 3 out front, so I put a 3. The vertex was -5, so x plus 5. And the second part of the vertex was -2, so on the outside, -2. Easier than doing it the legitimate way, but let's be honest, you really should know how to do the legitimate way, and I showed you a couple times. The first time was a little scuffed, but what are you going to do? I mean, we're at a 45-minute video here. Let's recap. Okay, so 1, 2, and 3 was complete the square, and all you had to do was figure out what the number was. So I had v squared plus 14v, and I had to figure half of 14 is 7. 7 squared is 49, so 49 is the perfect number to complete the square. Likewise, on number 2, half of 16 is 8. 8 squared is 64. And then on this one, half of -10 is -5, and -5 squared is positive 25. You'll always get a positive when you complete the square. Okay, on 4, 5, 6, and 7, I showed you how to solve these equations by moving the number over, then completing the square, allowing you to turn it into this appropriate squarular form, and then we solved it out. On the last problem, I showed you how you could graph it just to get the solution, but graphing it does not give you the form. There's no way to cheese it to get the form. You have to complete the square. Then on 8, 9, and 10, we had to put these in vertex form, write the vertex, graph the thing. The vertex and the graphing of the thing wasn't a big deal. Really getting the form was the hard part, especially on the first problem because I'm kind of a dupe and I got divided wrong, but then we went back and fixed it, so it's okay. And then I showed you how to do that again on 9, and on 10 I showed you how to kind of graph it just so you can get the answer by graphing. But I would not recommend that. Obviously, you want to do it the legitimate way. And that's all I got to say about that. All right, well, that was a long one. I hope you enjoyed watching that. I'll see you on the next video. Bye.